All right, hello everybody. My name is Aaron Standard, and today we're going to cover a question that I've answered multiple times in different forms over the years, but it was time to make a video about it. How do I manage a long-running task inside an Akka.NET application? So this is a little bit bigger than just like awaiting on a single async operation inside an actor. I'm going to go ahead and use a real-world example here in the moment, but if you took a look at our video that we did on TextForge, a new SaaS service that we launched maybe a month ago, one of the things that TextForge has to do is synchronize a user's inbox initially when they sign up for the service. And if they sign up for the Pro plan and choose to sync their entire email history, that could potentially be hundreds of thousands of emails that all need to get brought in together. And that's going to look like tens of thousands of round-trip HTTP calls to the Gmail history API. And so that's a process that can take tens of minutes to go ahead and complete, potentially longer, depending on how big the inbox is. So you can't really reliably have an actor sitting there blocking on that operation because it'll be non-responsive. The other thing that might come up is some of these really big complex tasks are going to be subject to intermittent failures. Not every single one of those calls to the Gmail API might succeed the first time. So even within this big task we're waiting on, there might be a little exponential back off and retry loops that are in there. And then more importantly, in order for the application to really be responsive and reliable to things like software deployments or scale up or scale down, we need the ability to cancel those long-running jobs either when the user requests it or when the system requires it during one of those operations I mentioned earlier. So we need to think through a little bit more carefully, how can we have actors manage these long-running jobs in a way where the system is still responsive? This is a slide I stole from our video we did a few years ago on async await versus PipeTo. These are the two different sort of task-based approaches to integrating with actors. And if I do like a little receive async in a receive actor here and I await on an operation, that is going to suspend the actor's mailbox. We're going to essentially block the flow of execution and keep processing all the await continuations for this message until it's fully processed. This is fully consistent with how await works in every other part of .NET, but the important detail here is that we can't begin processing the next message until the current await operation fully finishes. The entire await state machine has to complete in order for us to move on to the next message. If we compare this to PipeTo, which is an extension method that Akka.NET makes available on any task inside the .NET ecosystem, what this does is when we receive a message, we're going to spawn a detached task that runs outside of the actor's context. And when that task completes, it'll pipe its results back to, it could either be us or we could send it to a different actor if we want to, but it'll send the results as a typed message that'll land in someone's inbox, and that actor will process those results whenever it gets scheduled to process that message. So PipeTo allows us to have an asynchronous task that doesn't block a thread, just like await does, but it also prevents the actor from blocking its flow of execution as well. So instead, it kind of kicks all of that work out to a background thread. That thread does its work and then delivers the result to us once it completes. This is the pattern that we're going to use for managing a really long-running task inside of Akka.NET. Now, the pattern for doing this, for trying to manage a long-running task, is 4 points. The first is we need to declare a cancellation token source somewhere inside our actor managing the task. This is how we enforce cancellation. So we're going to do that. The second is we're going to use this fire and forget PipeTo pattern. That's what we just saw on the previous slide. So essentially, the actor is not going to be executing the work in its own context. It's going to be managing an external long-running task that is doing all that work on a background thread somewhere. And what the actor is responsible for doing is going to be managing the cancellation state of that task, spawning that task when it's initially requested, and then doing things like not allowing a second task to run until the first one completes, handling errors that come up if the task fails for some reason, and then handling the completed output once the task is done. We're going to go ahead and take a look at some source code from TextForge, actually, which is, this is private source code, but it's real enterprise-grade resiliency code that we're using every day to go and sync people's mailboxes on the platform, and these belong to paying customers. So it's a good example for us to look at. Let's dive into that next. All right, so this code here belongs to the MailboxSync actor. As the name implies, this is the actor responsible for synchronizing an individual email account. Now, we kind of abstract away who the email provider is. Right now, we only support Gmail, but we're going to add support for things like Office 365 and regular old IMAP down the road. And this will work with all of them. It's the same fundamental design under the covers. So the way this actor works is that when we get a start user sync instruction, and this is usually sent to us via Akka reminders on a schedule, we're going to go ahead and check to see if a sync operation is already in progress. And if it is, we're going to ignore it. There's no benefit in syncing twice. The sync system will catch it. Next, we'll go ahead and basically do some access checks down here. That's all about whether or not the user is basically paid their bills, more or less. And then finally, we get down to the real deal here. This perform sync async, a little bit of a mouthful, command that's going to go ahead and run the job in the background. So what we're doing here is this is an async local function that's going to kick off our detached task. So we're going to add a little bit of open telemetry tracing here. And then here's where we begin working with the cancellation token. We have declared up here inside the actor state this sync cancellation token source. And we go ahead and create this. Whoops, didn't mean to do that. We go ahead and we create this right as we begin starting the sync operation here. When I dive into this code, we're going to go and check to see if cancellation is requested. If it is, we're just going to abort, not even start. And then we actually begin doing our work with the database where we check our previous synchronization state. This is basically so we can talk to the Gmail history API and figure out if we're doing an incremental sync. Here was the last known sort of cursor position. And then I won't go through all the details, but we're going to have a branch here if we need to perform an initial sync, which means we have to get absolutely everything because we're starting from scratch. So that's a much larger operation. Otherwise, if we're doing incremental sync, we have kind of a more optimized path for that down here. But this operation, like I said, could take potentially minutes or tens of minutes to execute. If I get down to the very bottom here, you can see we have handling for things like OperationCanceledException when the cancellation token's been fired. We'll go ahead and just reply back with a little result type here that indicates that the sync got canceled. If we get an exception back from Google, so for instance, if someone revokes their Google OAuth 2 credentials from the Google side, we might bump into that the very first time we start syncing. And based off of some of these different statuses here, we'll go ahead and return an appropriate error message. And some of this might actually trigger activation emails being sent back to the customer saying, hey, you need to reconnect to Google. So this is sort of what a real long-running operation looks like. And the important other detail of this is that once we go ahead and begin, let me go back to the function here. Once we begin this attached operation, we exit. We're done processing messages, but we can still respond to other messages that get sent to us. For instance, if we get a stop sync command, which might be usually in this system, a user is not going to cancel it. It'd probably be the result of the system needing to cancel it for some reason, such as we're basically in the process of, I don't know, closing this user's account and there was a sync already in progress, something like that. We would go ahead and basically invoke the cancellation token here, and that's going to stop that long-running job in its tracks because that cancellation token gets piped into every single HTTP call and every database call that we do. That'll cause the job to stop. And one other little detail, if I find the PostStop in here, there we go. PostStop is an actor lifecycle method, and we've covered this in numerous videos. But down here, we go ahead and we also cancel any long-running jobs. So in the event that this actor gets shut down, and this might happen during something like Akka.cluster shard rebalancing, we are going to go ahead and cancel the long-running job. That way, it's not doing a whole bunch of work that's going to get piped to someone who's not listening. So that's one of the good reasons why we do that. And then that just goes ahead and gracefully shuts everything down at the end. So that's what a good production code sample of doing this sort of background sync looks like. We're going to hop back over to PowerPoint for a second, and then I have an open source sample that we can take a look at where you can actually go and kick the tires on this yourself. So this is kind of a visual breakdown of what that actor was just doing. We basically check to see if an operation's already in progress. With this specific background actor, it only wants to allow one operation per entity at a time. If in your domain you want to have multiple operations per entity at a time, you should probably look at using something like the child per entity pattern and just have a bunch of different child actors all performing more or less the same type of guarding work in parallel. One thing that I think is important is that jobs that are long running like this have unique identifiers so they can be looked up again. In the case of TextForge, we look up basically users based off their inbox ID. And that inbox ID is scoped to a global unique email account. So we can always reliably locate whether or not there's a sync job in progress for that customer at any given time. We want to cancel the previous job if we're trying to cancel it. And then basically if we get a new request for a job coming in, we're going to create a brand new cancellation token source. And then we're going to kick off the asynchronous work and have PipeTo deliver the success or failure message to us. Now, one thing I do think is a little useful is this statement down here. You probably missed this when I went through my code in TextForge, but I also checked to see if the operation canceled exception came from our own cancellation token. That means that we canceled it on purpose, and that's different than something inside the bowels of our long-running job failing because of like an internal timeout or whatever. So for instance, if we have an HTTP client exception that didn't get handled as a result of a request to Google that never got completed, that operation canceled exception that might be thrown by that HTTP client is not the same as our cancellation token that runs the entire job. So as a result of that, you want to go ahead and kind of differentiate between where the cancellation came from. That's going to be a useful heuristic to figure out what you should do in response to this happening. Now, one thing I'll go and end with here is that in our Academic code samples repository, and I'll link to this in the description, I actually created a kind of a simplified version that simulates like a CSV input that you can use to actually test this out yourself if you want to. So this is a much simpler version of what our MailboxSyncActor does. This pattern is really reliable. We've got customers who use it for like media transcoding and really long-running ETL tasks. It works, it's reliable, and it's very, very simple. So go ahead and give it a try and let us know how well it works for you in the comments. Thanks for watching. Well, that'll do it for this video. If you found this video useful, please don't forget to check the description to find links to other resources we may have included, so blog posts, GitHub code samples, other videos, so on. And as always, don't forget to like and subscribe and ring the bell for notifications. We'll catch you next time. Thank you very much.